Okay, going to be working the homework here for 7-6, graphing sine and cosine. And we're going to be starting off here with number 21. Now, number 21, it says, determine, bad marker here. See if any of these markers are good. That one's not bad. That one's okay. All right. Let's see. So determine the amplitude and the period without graphing. So we have y equals 5/3 sine of negative 2 pi over 3x. All right, so we start off with the basic idea here is that if we have y equals a sine of, let's make sure I match the book here. Yeah, okay, here we go. Omega x. All right, so if we have this, then the amplitude is the absolute value of A, and the period is going to be 2 pi over omega. All right, so we take 2 pi and divide it by that number, gives us our period, take the absolute value of that number, gives us our amplitude. This works for sine and cosine. So the amplitude here is just the absolute value of 5/3, right there, which is just 5/3. And then the period is going to be 2 pi over negative 2 pi over 3, which is the coefficient on x, this number. So we need to make sure we know what we're doing here. This is 2 pi over 1 over negative 2 pi over 3, which I can turn into 2 pi over 1 times, so division is the same as multiplication of the reciprocal. So I flip over the denominator like this, and then I can cancel out the 2 pi's, and then I should just get negative 3. Now, when it comes to the period, you really just want to know the distance, okay? So it's the actual distance it takes to complete one cycle of the sine. So you're looking at that distance, and we're getting negative 3. So if you look at it as a distance, then this is just 3. Now, let's see, do they use the absolute value here? Let me just double check something. Yeah, Yeah, they don't mention that here. Yeah, let's go 2 pi over omega. Okay, well, they're putting it, in the back of the book, they're saying the period is 3, so we'll go with it as a distance. So we'll go with 3, even though we did get negative 3. All right, so that's that one. Let's work on number 23, 25, 27, 29, and 31 are all matching the graphs. So let me try first number 23. Oh my gosh, these are all dead. Go with this one. Okay, 23. Okay, I'm gonna have to get my own markers here. I don't understand. People leave these in here and they're all dead. I'm just gonna get rid of them. Sorry, stand by. Stand by, stand by. Okay. I don't have a black marker today, I just have purple and blue, so that's gonna do it. All right, 23. So they give you y equals 2 sine pi over 2x. All right, so if we're going to do this, We could just graph this, which is what I would recommend we do, even though the instructions just want us to match it. I'm never really going to ask you to match anything on a test, so I'd ask you just to graph this by hand. So the way that I am going to teach you how to do this in class is that what you're going to do is you're going to take this argument right here inside, you're going to set it equal to two different things. Since we're dealing with the sine function, we know that normal sine function does this. So what we're going to try and do are figure out where these x-intercepts are. And to do that, we set the argument pi over 2x equal to 0. And then we also set pi over 2x equal to 2 pi. So we're basically trying to figure out where this one and this one happens. And when we solve this, you get x is 0. And when you solve this one, you multiply both sides by 2 over pi. Multiply by 2 over pi. The pi's cancel here, you just get 4. So x is 4. So now what we can do is we know on our graph that we have x-intercepts for this sine function at 0 and at 4. And then we use the fact that there are these quarter way points, which is here, here, and then here. So this is a quarter of the way, half the way, 3/4 of the way. So I'm going to split this up. First half of the way, and halfway between 0 and 4 is 2. Then halfway between 0 and 2 is 1. And of course, halfway between 2 and 4 is 3. So I know those points exist. And I know that my middle point is going to have to correspond to another x-intercept. Now it's just a matter of determining how high this thing goes and whether or not it goes like this, or like this. And so to do that, what I'm going to do is I'm going to take this point, and I only need one of them. I'm going to take this point, x is 1, and plug it into the original function. So if I plug in 1, I get y equals 2 sine. If I plug in 1 for x, I just get pi over 2. Now, sine of pi over 2, I figure out what that is. So pi over 2 is straight up. Sine is my y coordinate. On the unit circle, I should get a 1. So this is 2 times 1, which is 2. So I know at 1, I'm up 2, which puts me here. And now I can see the behavior of this sine function. It goes up like this, comes back down. And I know at 3, it's got to go down to -2, just by what I know about the shape of the graph. So -2 down, back up to 4. That's it. Now if I wanted to, I could go backwards. -4, -2, -1, -3, and I could continue this graph backwards. I would have x-intercepts here. I would come down to -2, come up to 2 here, and go like this. And that would give me 2 periods of this sine function. So what does that match up with? That matches up with graph F out of the book. Wait, hold on. Grab E. What? Oh, okay. F is, I'm sorry, I thought the letter was above it. I was like, that's not it. Okay, so yeah, it's graph F. All right, now let's look at number 25. I'm going to follow the same exact format for 25. We have y equals 2 cosine of 1/2 x. Y equals 2 cosine of 1/2 x. All right, so to do this, I'm going to be using the fact that I know what a basic cosine function looks like. I know a basic cosine function starts off here, comes down, comes back up, like that. So again, we have like the halfway points, and then we have the quarter points, like this. Like that. So it's up here, down here, up here. And we're going to go try and figure out where these two endpoints occur. So let's take the argument, which is 1/2 x, and then let's set it equal to 0. Then we take 1/2 x and we set it equal to 2 pi, which is the standard technique that I show you for both graphing cosine and sine. So the solution here is x is 0, and then here x is 4 pi. So what that tells me is on the graph I'm going to draw, I start out at 0 and it ends at 4 pi. So I know it's either going to be 2 points up here or 2 points down here. And then I have the middle point, which is halfway between here and here, which is 2 pi. This would be pi, and halfway between here and here would be 3 pi. So I can use this graph to use the first quarter point and the 3/4 point to know right now that I should have x-intercepts here and here. Hold on a second. Getting a phone call. Never stops. Okay, sorry about that. Apologize. Okay, so we know because it's a cosine, we can put these 2 points on at the quarter and 3/4 marks. It's just a matter of, again, are the other points up here or down here? So to do that, I'm going to pick, instead of these two, or one of these two, I'm going to pick this first point, 0, and plug it into my function. So y equals 2 cosine of 1/2 times 0 is just 0. And cosine of 0 is 1. So 2 times 1, that should give me 2. So I know that at 0, I'm up here at 2. And that automatically makes it look like this. So I go straight across. Up here, I'm at 2. And that means at 2 pi, I'm down here at -2. And then I can draw my graph through like this. And then we could continue another period if we wanted to. But this should be enough for us to match that up. That's graph A. Okay, let's look at number 27. Y equals -3 sine of 2x. All right, so on this one, same story. I know basically every sine function looks like this. And got those points and then my quarter points there. And so I just need to figure out, you know, where these two things happen. So I set 2x equal to 0. I set 2x equal to 2 pi. I solve these, I get 0 here. And here I get, if I divide both sides by 2, I just get x is pi. So finally we're going to have some fractions here. So I know my graph is going to start here at 0 and end here at pi. Since it's a sine curve, I know I have dots at the ends and in the middle. So halfway here is pi over 2. So I've got dot here, dot here, dot here. And then halfway between here and here is pi over 4. And this one right here is 3 pi over 4. So far, getting these quarter points has not required too much thinking. I hope that it's okay that halfway between here over here is pi over 4 and halfway between here and here is 3 pi over 4. But just to remind you, if you get to a problem where you're not quite sure what this middle one is, you take this one and this one, pi over 2 plus pi, and you take their average. So you divide it by 2. And so first you have to get a common denominator on the top. So you do pi over 2 plus 2 pi over 2. So that's putting a 2 on top and bottom here. And then all this over 2. And then this is going to be 3 pi over 2 on top. And then over 2, which is 2 over 1. And then when you flip this like this, it becomes 1 over 2 and multiply. You get 3 pi over 4. So you always, if you want to find the point in between 2 points, you take the average. You add the 2 points and divide by 2. All right. So now, how am I going to figure out if it looks like that or like this? Well, I pick a point to test, and I don't want to pick I don't want to pick this point, this point, or this point, because I know those are 0. I'm really interested in either this one or this one. So I'm going to just take the pi over 4. So y equals negative 3 sine of 2 times, and I'm plugging in pi over 4. So 2 times pi over 4 is the same as pi over 2. And sine of pi over 2, we're straight up again, is 1. So I'm getting negative 3 times 1, which is negative 3. So I know that at pi over 4, I'm actually down here at negative 3. And that means at 3 pi over 4, I must be up here at positive 3. And then I know it's got to look like a sine curve, so like this. And then I could extend it, but that should be enough for me to get the graph. And it looks like that's H, graph H. All right, let's look at 29. Okay, so for 29, y equals negative 2 cosine of 1/2 x. Y equals negative 2 cosine of 1/2 x. Okay, I know that cosine looks like this. Got those 2 points there. Okay, so I'm going to go try and find out where these 2 endpoints are first. Now, I don't know if they're up or down yet, but I can still find where that period is going to start and stop. So I take the argument, set it equal to 0. I take the argument, I set it equal to 2 pi. This solution is 0, and then this solution here is x is 4 pi. So we've seen something like this before. Go to my graph. Here's 4 pi. Halfway is 2 pi, and then get my quarter marks there. So far that math is pretty clean. I know that these 2 points are on my x-axis, and now I just need to figure out where these 2 are in this one. So I need to figure out what's happening at 0. So I go into the original equation up there, and I replace x with 0. When I replace x with 0, I get cosine of 0. Cosine of 0 is 1, so this just gives me negative 2. So at 0, I'm at negative 2. And if that point's down here, then it's like that one being down here, and then that one has to be down here, and I know my curve's going to look like this instead. So I know at 4 pi it's here, and that means at the middle point I'm up at the top at 2. And so it's going to look like a little curve there, curve there, curve there, curve there, like that. So that looks like graph C. All right, 31. For 31, y equals 3 sine of 2x. All right, right, I'm going to try and do this one without drawing the basic sine function first. I'm just going to go straight to setting this equal to 0 and setting it equal to 2 pi. I get 0 and I get pi. Come to my graph. I know this is at 0 and at pi. And since this is a sine function, I know I'm going to have a dot here, dot here, dot here. Half of that is pi over 4, and half of this between these two is 3 pi over 4. So I just need to figure out right here if I'm up here or down here. So I'm going to plug that in. So y equals 3 sine of 2 times pi over 4. So this right here is pi over 2. And sine of pi over 2 is 1 again. So I get 3 times 1, that gives me 3. So up here at 3, I have a dot, and that means over here it has to be down at negative 3. So I go up, curve there, down curve, like that. And that looks like J is the option. All right, now we're going to start doing these graphs. It's not multiple choice anymore, but that means I'm just going to continue doing what I'm already doing. 33. So I've got y equals 4 cosine x. Okay, this one's pretty straightforward. Set x equal to 0, x equal to 2 pi. So you already have your answers there, okay? So I've got at 0 and at 2 pi. Halfway is pi, half of that's pi over 2, and then this is 3 pi over 2. All right, so once you get those, it's a cosine function, so you know it's at the first quarter mark and the 3/4 mark that you have a dot. And then you just have to figure out what's happening at 0. So we plug 0 in here, get y equals 4 cosine of 0. Cosine of 0 is 1, so that just gives you 4. So at 0, I'm up here at 4. And I'm going to be down at negative 4. So this dot's up here, so that means straight across it's got to be that. And in the middle, it's got to be down here. So it's got to arc down like this. Ooh, that was bad. Then that, then that, then that. There you go. Okay, I'm just going to draw one period of that. Okay, number 37, next. Cosine of 4x. So what's the difference between 4 cosine of x and just cosine of 4x? And this will be number 37. Okay, so the difference here is, notice that the argument's 4x this time. So when we set that equal to 0 and set it equal to 2 pi, we get answers are going to be a little different here. 0 and pi over 2 when we divide both sides by 4. So now our graph ends at pi over 2, starts at 0. So halfway between there and there is pi over 4. And halfway between 0 and pi over 4 is pi over 8. And then halfway between here and here, let me try and do this real quick, just again to show you. Take pi over 4, I'm going to add pi over 2, and divide by 2. That's pi over 4 plus 2 pi over 4, getting a common denominator, all over 2 over 1. This is going to be 3 pi over 4 over 2 over 1, and then when you reciprocate, you get 3 pi over 8. So 3 pi over 8. All right. Now this was a cosine function, so I know I'm going to have a dot at the quarter mark and the 3/4 mark. And now it's just a matter of knowing if the 2 points are up at the top or 2 points are at the bottom. So I'm going to plug in, let's say 0 again. Y equals cosine. When we plug in 0, we get 0. So cosine of 0 is 1. And so we know at 0 we're at 1. That means straight across we're at 1, and that means halfway we're at negative 1. And then we connect. That's it. Okay. Now, next one, number 41. Yeah, 41. 2 sine of 1/2 x. Wait a minute. Did we already do that one? Oh, no, we didn't. Okay, 41. Y equals 2 sine of 1/2 x. This is starting to feel a little monotonous now, but we'll get it done. We set the argument equal to 0, set the argument equal to 2 pi. Here we get 0, here we get 4 pi. Try and go a little faster through this one. This is 4 pi. This is 0, halfway is 2 pi. Half of that's pi. And then this is 3 pi. It's a sine function, so I know it's boom, boom, boom. Right? And now I need to figure out if it goes up like this or if it goes down first. So to do that, I just plug in pi. So 2 sine of, when I plug in pi right here, I get half of pi, which is pi over 2. Sine of pi over 2 is 1, but then multiply it times 2, you get 2. So here I'm up at 2. Going to be down at -2 at the midpoint, and at the very end, at the 3/4 mark up here. So it's going to go like this. Oh wow, I jacked this up big time. Hold on. Back. At this, I'm at 2. That means at 3 pi, I'm at -2, and then back up to 0. That. Okay, next one. That was 41. 45, finally. Sine of 2x plus 3. All right, so finally we have something that's outside of the trig function, plus 3. All that's going to do is move our graph up 3. So the way you should graph this is ignore that for now and just try and give a rough graph of sine of 2x. So I set 2x to 0, 2x to 2 pi, get x is 0, x is pi. So I know for starters, my graph should start at 0, end at pi. This should be pi over 2. This is pi over 4. This is 3 pi over 4. Now, because it's a sine function, I'm going to do this in red because I need to move my graph at the end. I need to take count for that plus 3. But for now, since it's a sine, it should start here, have a middle point and an end point, and it either does this or it does that. So I test a point, pi over 4, and watch what happens when I plug this in. Y equals sine of 2 times pi over 4. Notice I'm not doing the plus 3, just doing this part first. So when I plug that in, that's pi over 2. Sine of pi over 2 is 1, so I'm going to be up at 1 there. So if this is 1, this point goes right here, and that means -1 is this point right here. So my graph looks like this. That's just this part. Now to do the plus 3, what I do is I come in here and I just add 3 to all my y values. So this was 0, I move it up. 1, 2, 3. 2, 3. Let me move this up a little more. I'll get rid of this. So this point comes up 3, 1, 2, 3. This one right here was at 1, it comes up 2, 3, 4. So it's going to go up to 4. This point was at 0, so it comes up 1, 2, 3, it comes right here. And this point was at -1, so it comes up to 0, 1, 2, so it's at here at 2. This one was at 0. Wait, it was at -1, comes up 1, 2, 3. This one was at 0, 1, 2, 3, so it goes here. So you can kind of see, it's almost like our x-axis has moved up to here. And then we draw our curve like this. There we go. That's it. So this is the graph of this function. Okay, next. Number 47. I need to cover that up so I don't do. Number 47, 5 cosine pi x minus 3. Am I on camera here? Yeah. Y equals 5 cosine pi x minus 3. Yep. All right. So lots going on here. We're going to ignore the minus 3, which is going to move every point down 3. We're going to start with this piece and try and draw a graph. So I set pi x equal to 0, pi x equal to 2 pi, because it's a cosine function. That's my standard approach. I get 0 here. I get 2 here. Oh, good. That'll be easy to cut up. So I start out 0 to 2. Halfway is 1. Half of that's a half. And then this right here is 3 halves. Kind of cool. You could take these 2 points, 1 plus 2, add them together, and then divide by 2. You get 3 over 2. Yeah, 3 halves, just like we were supposed to. Now this is cosine, so I know I'm going to have a dot here and a dot here. Now actually, let me switch to red because this is not my final graph. I've got to move it. So now I'm going to have a point here and a point here. Since it's cosine, I either have 2 points up here or 2 points down here, so I pick a little test point like 0, and I plug it just into this piece. I ignore the 3. 5 cosine, and when I plug in 0, I get 0 in there. And cosine of 0 is 1, so I get 5. So this point is going to be up 5. All right. When I plugged in 0, I got 5. So I'm going to need to extend my graph up. All right. Let's say that that's 1, 2, 3, 4, 5. So I have a point up here. And then that means over here at 2, I'm up at 5. And then at the halfway point right here at 1, I should be at -5. 1, 2, 3, 4, 5. There's -5. So I should be right there. So a rough picture of my cosine function before I do that shift, that vertical shift, it's actually vertically down. That's my picture. So let me now take that and move every point down 3, and that'll be my final picture. So this point comes down 3, 1, 2, 3. This point comes down 3, 1, 2, 3. This point comes down 3, 1, 2, 3. I'm at -8. And then this point comes down 3, 1, 2, 3. I'm right across from this one. This point comes down 3, 1, 2, 3. I'm right across from that one. So I'm there. You can also imagine that your x-axis went down 3, 1, 2, 3. So it's almost like our x-axis goes through here now. And so our picture looks like this. There we go. That's our picture. All right. Number 51. 5 minus 3 sine 2x. Y equals 5 minus 3 sine 2x. Yep. All right, so this may look a little different because of that 5 in front of that, but let's first just rewrite the function so it looks a little bit closer to what we've been working with. This is the same as -3 sine of 2x plus 5, just rearranging that. And now we can ignore the plus 5, which will move everything up 5 at the end, and just focus on this piece. I'm going to set 2x equal to 0, 2x equal to 2 pi. I'm going to get x is 0 here. I'm going to get x is pi. And now I'm going to have a pretty big y-axis there. So 0 to pi, so 0 to pi. Cut this in half, I get pi over 2. Cut that in half, I get pi over 4. Cut that in half, I get 3 pi over 4 here. All right. Now it's a sine function, so I know that I'm going to have points beginning, middle, and end. And now it's just a matter of does it, do that or does it do that? Well, how about a test point? So I test, let's do pi over 4, and I'm going to plug it just into here. So when we do that, we get -3 sine of 2 times pi over 4. This is pi over 2, sine of pi over 2 is 1, but then I'm multiplying times -3. So I get -3 there. So let me put some numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at pi over 4, I'm at -3. 1, 2, 3. So I'm here. So I know it goes like this and then comes up. That means that here it's +3, which is there. Okay. And so my basic curve looks like this before I've moved it up by 5. So now I need to add the 5, so every point comes up 5. 1, 2, 3, 4, 5. There. This one, 1, 2, 3, 4, 5. That's now at 2. This one was at 0. Now it's going to come up 5. Yeah. 1, 2, 3, 4, 5 right there. And then this one was already at 3, so that's going to go all the way up to 8. Right about there. And then this one is going to come up by 5. It's going to go right about there. Our whole x-axis came up by 5, so you can imagine here's 5. You can almost imagine like our x-axis is going through like this now. And our graph looks like this. Like that. So it's that red curve moved up 5. All right, number 57 is different. Number 57, they say, hey, look, you've got an amplitude of 3, and you've got a period of pi. So give us the equation. So remember, y equals amplitude, and they want, right, the sine function. Okay, so they want sine of omega x. They want us to come up with an equation. They give us the period, and they give us the amplitude. So we know right away that a can either be 3 or negative 3, and it really, there's 2 possible answers for this problem. You could use a negative 3 and the amplitude would still be 3. So this could be positive or negative 3, up to you. Then sine of omega x. Now the question is, what is omega? So you go back to the definition of omega. Omega is 2 pi, the period is 2 pi over omega. And I know the period must be pi, so the left side of this equation has to be pi, and I want to know what omega is. So what I can do is I can multiply both sides by omega, and that'll get rid of them over here. Then I have omega pi equals 2 pi. Then I divide both sides by pi, and I get omega must be 2. So that means this has to be a 2. That will give you a sine curve that has a period of pi and has an amplitude of 3. And like I said, you could make that a negative 3, and that would be a correct answer still. Okay, number 57 we just did. How about number 61? Number 61, find an equation for each graph. All right, so this is going to take me a second to draw this. So let's see, it starts up here at 5. And it looks like at 10. And then, man, it's hard to read this. Okay, yeah, I can see what's happening here. Here's 8. Here's 2. Here's 4. Here's 6. Here's 8. Let me redraw this. And then here's 10. So at 0, we're up here. At 2, we're here. At 4, we're at the bottom. And that looks like we're down at negative 5. And then at 6, we're here. Then at 8, we're up at 5. And then it starts to come down again, 10 here. So this is the picture they give you. And it goes down. And then they actually go backwards like this too. Okay, so how are we going to identify the equation for this? Well, let's just look in here for one period. And I can see that we have a full period. Well, it looks kind of like a cosine function. It starts here, comes down, and goes back up like this. So our standard cosine function looks like that. It goes like that. It's got 2 points up here. It's got these x-intercepts, and it's got a point down there. So we have our x-intercepts here, got our point down here, and 2 up top. So it looks like the amplitude of this thing is 5, right? The amplitude is 5, so I can already start out by saying, okay, it's 5. I also know it's cosine. And now what's the period? Well, it looks like it does this entire blue curve between 0 and 8. So I know my period, which is 2 pi over omega, is 8. So 8 must be 2 pi over omega. And then multiplying both sides by omega, I get 8 omega equals 2 pi. And then dividing both sides by 8, I get omega is pi over 4. So if I put pi over 4 here, x, this should take care of it. Let's just double check. The only thing I'm concerned about is was it flipped over maybe? So let's just check. If we plug in 0, we should get 5. So if I plug 0 in here, I get 0. Cosine of 0 is 1, and 1 times 5 is 5. So yes, that does work. And I'll check one more thing. What would happen if we plug in 8? We should get 5 again. So I plug in 8 right here. 8 over 4 is 2, so we have 2 pi. And cosine of 2 pi on the unit circle, 2 pi is all the way around. Cosine is the x-coordinate there, that's 1. So this thing comes out to be 1 times 5 is 5. So you have these 2 points match up, so we're feeling good like this equation works. So I'm going to say check. Now there are some other ways you could have done this that would have been a little harder. Yeah, and I don't want to confuse you, so I think I'm just going to leave it like that. But just keep in mind that there are other answers to this that are correct that don't look like that function. All right? That you can actually get that same picture out of a sine curve, but the equation is going to be a little more complicated. Okay, what's next? That was 61. 67, got another picture. Okay. Looks like we've got, starting here, comes down, then up, and over, then up, then comes down and continues. And then this way it continues. So what I'm doing right now, I'm trying to figure out what's that amplitude. The amplitude looks like the highest here is 1, and this is -1. And then it looks like this midway point is 2 pi over 3. And this one right here is 4 pi over 3. So when I look at that, I kind of see like your sine function starts out like that. That's sine. Negative sine reflects it over the x-axis. So that's a negative sine function. So I'm thinking what I'm going to need to do here is use my amplitude, which looks like it's 1. And instead of using +1, use -1. That will give me the graph that goes like this instead of like this. And then I'm going to use the sine function. And then I need to know the period. So look at the period. It starts here, ends here. So it looks like my period is 4 pi over 3. And that's 2 pi over omega. So we've done this a few times. Multiply both sides by omega. And then I'm going to divide by this, which is the same as multiplying both sides by the reciprocal. So let's multiply both sides by 3 over 4 pi. And we'll get our 3's and 4's and pi's to cancel. We'll just have omega there. Then over here, our pi's cancel. And then 2 over 4, that's a 1, that's a 2. I should just get 3 halves when I'm done there. So that's omega. So if I put 3 halves x here, that should do it. Now we could check if we wanted to, but I think that's pretty straightforward. So yeah, okay. All right, last one I believe is number 85, which is an application or extension. And it says alternating current, AC circuits. The current I in amperes flowing through an AC alternating current circuit at time t in seconds is given by this function. So they give you this function, I of t, is number 85. I of t equals 220 sine of 60 pi t, and they tell you that t is greater than 0. T is time, so that makes sense. It says, what is the period, what is the amplitude, and graph this over 2 periods. All right, so amplitude, straightforward, is 220, because this is a sine curve, the amplitude is 220. The period, I'll just put P, is 2 pi over this number, which is 60 pi, which is 1/30th. All right, that's answering the first 2 questions. Now they want us to graph it. So to graph this, I'm gonna do what I've been doing. Take 60 pi, t instead of x, set it equal to 0. I'm gonna take 60 pi t and set it equal to 2 pi. The only way to get that to be 0 is if t is 0. Here we divide both sides by 60 pi, and we get 1/30th. We kind of knew that already. Now I'm going to graph 2 periods, so let's pay attention to what I'm doing here. 1 period would be 1/30th. Here's 0, so 0 to 1/30th. Another period would be 2 of these, so 2/30ths, which is the same as 1/15th. This is t, this is time, right? And then I, which is current in amperes. All right, so that's going to be my 2 periods. Now, let's start with the first period. The first period here, I'm going to need my section. So I cut that in half. Half of this, okay, half of 1/30th. You take 1/30th and divide it by 2 over 1. And that means you flip, you get 1/60th. Okay, and then halfway between here and here, this is 1/120th. Okay, halfway between here and here. So if I take 1/60th and 1/30th, add them together, and then divide by 2, I need a common denominator. So 1/60th plus 2/60ths over 2. This is 3/60ths over 2 over 1. So then I flip, and I get 3 over 120. All right, yeah, 3 over 120, and that does reduce. That's 1/40th. Okay, so that's going to be right here. Let me just do a quick check. 1, 2, 3, and then 4. Okay. 4, yes. Okay, so those are my points. And it's a sine curve, so I know since it's a sine curve, I'm going to have the beginning and the end have dots in middle. And then I know the same thing's going to happen over here. So I could do halfway, quarter way, like that. So I'm doing a separate period here. I could find the point between these two, right? But there is, because we start at 0, there's an easier way to count this, to count out these intervals. This is 1/120th. This is 2 over 120, which reduces. This is 3 over 120, which reduces to 1/40th. This is 4 over 120. Which reduces. This one would be 5 over 120. So if 5 goes into that, we can cancel a factor. 5 goes 2. Can't do math. 24? Is that right? Hold on. Yeah, 24. So this is 1/24th. Why does that not look right? 120. I can't do simple math. Divided by 5. Goes in there twice, and then that leaves me 10, and then 20. That's 4. Okay, 1/24. This one is 6 over 120. And then if we reduce that, we get 1/20th. And then the last one is 7 over 120. That one doesn't reduce, so 7 over 120. So those are my points. You could have also got these by doing halfway and all that stuff, but because you could start from the beginning, since it started at 0, you could just count. I've got 1 of these, 2 of these, 3 of these, 4 of these, 5. It's a little faster when you start at 0 to count that way. Okay, and I know that from here to here, it's another sine curve. So I'm going to have a point at the beginning, point middle, point end. And now it's a matter of, does it go up and then down, or does it go down and then up? And we could pick a test point. So if we pick 0, plug it into here, we're going to get 0 here. Sine of 0 is oh wait, I'm picking the wrong test point. I already know what my value is. It's 0. My apologies. I need to pick 1/120th because I want to know if that's up or down. So if I plug 1/120th in there, let's see what I get. 220 sine of 60 pi times 1 over 120. and 60 and 120, that becomes a 2 down here and a 1. So this is really like pi over 2. Sine of pi over 2 is 1, and then times 220. So I know I'm up here. Let's say that that's 220. I'm up here. And that pretty much lays everything else out for me. I know I've got to go up like this, come down. This is going to come down to negative 220, come back up, and then at this quarter mark up to 220, back down to negative 220, and then back up. So this is negative 220 there, like that. So that's your 2 periods of that alternating current circuit function. And that's it for this section. I am done.